Hello, fifth graders. Today we are going to be talking about line plots. So we're going to talk about how to analyze data that is displayed in a line plot. So if you have your book, you can turn to page 700 in your book to kind of read along with me as I talk about this one example. So a line plot or dot plot shows data along a number line. So basically data, all that really is just collected information. Each dot or X represents one value in the data set. So in science class, Abby and her classmates performed an experiment in which they used different amounts of vinegar. The table below shows how much vinegar each person used. So if we look at this table, she collected from her science class. So I see 1, 2, 3, 4, 5, 6, 7 times 3. I see 21 things that were collected. So that means that Abby and her classmates, so there was 21 of them. This was from one person, this was from another person, this was from another person. So we're going to use this collected data, this collected information to make a line plot. And what it says in this speech bubble right here, it says a line plot shows how often each value occurs. So first you need to know how to read a line plot. So from this information, from this chart that Abby and her classmates collected, okay, she made a line plot. So this is an example of what a line plot looks like. So a line plot can be used to organize the amount of vinegar each person used. So you can see from this data here, it's kind of all jumbled. It's really hard to kind of see exactly who had the most vinegar, who had the least amount of vinegar, it's very jumbled. It's hard to read. But when it's in a line plot, it's nice and easy to read. So you can see, okay, 2 people used a half cup of vinegar. I could see 1, 2, 3, 4, 5 people used 3/4. Right away from this line plot, I can see, oh, well, the most amount of people used 1 cup of vinegar because there's the most amount of dots in one. Without even counting, I could just see, ooh, it's the tallest. Okay, so you can see that most people use between half a cup to 1.5 cups. It ranges from there. And then you see 1 3/4, 2 cups, 2 1/4. Not really a lot of people use those amount of cups. And then all the way down here, you see 3. One person used 3 cups, when the majority of people used half, 3/4, 1, 1 1/4, and 1.5. So this person, the only one person that kind of stands alone, has a certain name. And that's called an outlier. So basically an outlier is any value that is very different from the rest of the values. I like to think of an outlier being like it lies outside of the data. So this number, this 3 cups, that one person that used 3 cups, it lies outside of the rest of the data. It's far away from everything. So that's called an outlier. So they said the dot above 3 is far from the rest of the other dots. This value is the outlier. So let's look at an example. So again, if you have your book and you want to look at this with me, it's on page 701. So let's look at number 4. It says, Mr. Rice's students ran a 40-yard dash in the following times in seconds. So I'm seeing all these times. Whew, that's a lot of numbers. I need to organize that information. So it says how many race times are recorded. Well, these are how many times. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 race times that are recorded. 16 different times. Now we're going to organize that data. So look, you can see for number 5, they organize it in a line plot. Okay, the line plot ranges from 6 8/10 to 7 3/10. They didn't extend it any longer because none of those times were before 6 8/10 or after 7 3/10. So you can see they just counted by a tenth. 6 8/10, 6 9/10, 7/10, 7 1/10, 7 2/10, 7 3/10 seconds. Without even counting, I can see, oh, well, the most amount of people ran 7 1/10. And if I did count, 1, 2, 3, 4. So the question is, which time occurred most often? Well, if it's organized in this nice line plot, I can easily see, oh, well, the time that occurred most often was 7 and 1/10 seconds. Now, what if I asked you which time occurred least often? So that means which seconds has the least amount of dots? That means that not as many people ran that time. And that would be 6 and 8/10. It only has 1 dot. So 7 and 1/10 was the most popular time. 1, 2, 3, 4, 5 students ran 7 and 1/10, but only 1 student ran 6 and 8/10. So line plots are very useful in just organizing information and helping us see in an easier way how the information is spread out. Now in this case, do we have an outlier? We don't have an outlier because all of these times are around the same. They range from 6 and 8/10 to 7 and 3/10.